Good morning, everybody. I'm Pete Chadwick. I'm Director of Product Management for Cloud and Systems Management at SUSE. And today we're going to be talking about mainframes and ZVM. And I'm joined by Kershaw Mehta from IBM. And in fact, we're going to start off with having Kershaw just talk about IBM's efforts in bringing ZVM to OpenStack. I'll finish up with some discussions around SUSE OpenStack Cloud and how we're integrating with ZVM, and then Mike Friesenegger is going to finish up with a demo, actually showing how that integration looks and how you can run both x86 workloads and ZVM workloads in the same SUSE OpenStack Cloud. So with that, I'll turn it over to Kershaw.
Thank you very much, Pete. Okay. So first and foremost, we're going to go about talking about what the mainframe is, the LinuxONE platform that we have created. We'll talk about OpenStack a little bit, and then as Pete mentioned over here, we're going to conclude the whole session talking about SUSE OpenStack Cloud 6 and then doing a demo about it. First and foremost over here, IBM has been in the mainframe business for well over 50 years. And our latest model of the mainframe is what we have branded as LinuxONE. And what we mean by LinuxONE over here, that brand over here, is essentially Linux your way, Linux without any limits, and Linux without any type of risk. Down on the showroom floor, in fact, you'll see one of these models over here, the LinuxONE Rockhopper model. That's out on the showroom floor. That's the smaller of the two models that we have. The other bigger one is the LinuxONE Emperor, which is essentially a double-wide version of the one that's out there on the floor. The mainframe that we have over here allows you to be able to have quite a few unique capabilities from an application standpoint. When people first see the rack that we have downstairs, their first question is, is this x86? And for those of you who might not be familiar over here, the mainframe has its own architecture. If you look at it from an open source standpoint and a package standpoint, usually when you see packages out there, you'll see a .86_64 extension for x86 applications. But for our platform over here, you'll see a .S390X extension for representing our architecture over here. It's our own architecture. We have our own instruction set over here, and we've had now SLES running on our platform for the last 16 years. Essentially, what we were able to do, as was mentioned by Aaron in the keynote on Tuesday, was that essentially the Linux kernel was recompiled to run with our architecture set. So it's the same exact SLES that you have on other platforms running on our platform. Now, the unique things that we have on our platform is the fact that you have diagonal scale capability. And what we mean by diagonal scale is not only can you do scale out, like you do on the x86 platform, we can also do scale up, meaning you can grow the partition, for example, that you have your workloads running in. And because you can do both scale out and scale up, you have essentially diagonal scaling. So that's a very unique proposition for our platform over here, because what it allows the customer to do is to either add more capacity to the existing frame that you have there, or you can go off and add additional frames or additional partitions to the machine to be able to go off and handle workloads. One of the unique things that we have within our architecture set is the fact that we have dedicated I/O processors within the rack. And what that really translates into is if you have a workload that's heavy into I/O, database application, for example, it doesn't make a difference which database. It could be MongoDB, it could be DB2, it could be Oracle. Whenever you have these high I/O type of applications, because we have dedicated I/O processors in there, what happens is as the application is running on the general purpose processor, anytime there's an I/O instruction that needs to get done, it will get offloaded onto the I/O processors. And then that frees up that general purpose processor to be able to go off and continue to do computing. Because we have our dedicated set of I/O processors, that's what allows us to be able to have very high I/O bandwidth and greater throughput with respect to database type of applications over here. At our booth downstairs, we have a video that actually demonstrates this. As more and more, for example, the demo that we have down there is as more and more containers are created, which represents more and more requests to the Mongo database that we have there. Your throughput remains to be the same. Your response time remains the same, but your Mongo requests continue to go up. So because we have these I/O processors over here is what allows us to do that. Yes?
Will you be showing any benchmarks to compare it against x86 or POW?
Sure. Actually, that's going to be on the next slide. In 1 or 2 slides, you'll see that over here. We've taken, for example, some Mongo workloads over here and give you the details of that. In fact, at the booth downstairs, we also have handouts for example, Postgres, MongoDB, as 2 examples that show that differentiation over here. This slide over here is supposed to represent essentially the wide ecosystem of products that we have running on the mainframe right now on LinuxONE. You have your traditional Linux distributors over here, of which SUSE has been a partner with us for the last 16 years from the very beginning. We have different virtualization technologies over here. We're going to focus mainly on ZVM, our proprietary virtualization technology that we've had on the mainframe now for well over 40 years. But we have other virtualization technology that's inside the space. Name your favorite language. We have that running on the mainframe. Python, Ruby, PHP, Erlang, Go, even the new Swift announcement that was made, where Apple Swift is making their code available, open source, etc. We have that running on the mainframe right now. Various different runtimes over here, whether you're talking about Node.js or OpenJDK, Apache Tomcat, those are all running on our platform. Different management packages that are out there, Chef, Puppet, Ansible, Salt. Those are all packages that are run on our mainframe. And then the variety of different databases, whether you're talking about SQL databases, whether you're talking about NoSQL databases, whether we're talking about open source databases, whether we're talking about proprietary databases, all of those are running on the mainframe over here. And then the wealth of analytics types of applications that are out there, whether we're talking about Spark, whether we're talking about Apache Solr over here, those are all applications that have been ported and run on the mainframe over here. Yes? Okay, let's keep on going over here. This is the one chart that I was referring to with respect to benchmarks over here. And while it's small over here, if you stop at the booth downstairs, we'll give you a little bit better example. But let's just use MariaDB over here as an example. With MariaDB, you're able to see anywhere from 1.8 to 2.1 throughput improvement on the sysbench benchmark that we have run against this against MariaDB. With MongoDB over here, anywhere from 2.2 to 2.7 throughput improvement on the YCSB benchmark. These are all, again, industry benchmarks that exist for these various different databases, and we've run those specifically for our platform.
Can you explain? I can't see.
Yes, sure. So what this is trying to show over here is the number, on the x-axis on all of these is the number of cores, or IFLs. In our case, we have, our cores are called IFLs, Integrated Facilities for Linux. And on the y-axis over here is the number of transactions over here. And the different colors over here represent, x86 compared to, for example, the blue represents our LinuxONE environment. The 2 different colors of blue over here is one for the smaller model, one for the bigger model.
The red is?
The brown or the red over here is for essentially the alternative platforms of x86. Okay. And so what you're seeing is if you do a comparison over here of the number of cores to IFLs over here, you'll see that on a given core, if you have 16 cores, for example, on an x86 side, your throughput is going to be about 15,000 transactions. With 16 of our IFLs or our cores that you can have well over 30,000 transactions running on there. Okay, and this is just MariaDB that I just explained, but the same thing is true over here for Mongo, Postgres, CloudInt over here, or these are all various different comparisons that we've done, benchmarks that we've done to be able to show the greater throughput over here of the given application.
So the cost, that's more important, right?
Yeah. So the cost over here really comes down to a whole entire TCO study over here that needs to get done, and the TCO over here involves software licensing, involves raised floor space that's being used, energy costs, etc. And while I haven't included it as part of this presentation, we do have entire presentations dedicated on TCO and how the TCO over a 3-year period of time is much lower running on a mainframe over here compared to an x86 environment, mainly because the mainframe is used for consolidation of workloads, right? Let's just use Oracle as an example over here. And this is true even for our own IBM software. Oracle today charges on a per core by core basis, for example. If you have an application today that runs on x86 that takes 400 cores, you can get a reasonable consolidation ratio on the mainframe of 10 to 1, 15 to 1. And so therefore, you're really only paying for 40 cores compared to 400 cores. Most of your savings that you get from an entire TCO standpoint over here comes about from software licensing. And we've done this comparison not only from a private environment, meaning x86 private in your own raised floor, compared to our LinuxONE, but also we've done that same exact study comparing, for example, running it in a public cloud environment using AWS. And in all those cases over here, the TCO over a 3-year period of time comes out to be cheaper on the mainframe than it does on those environments.
You have a rough percentage of how much?
For the given application we're talking about, it can be anywhere from 30% cheaper, 50% cheaper across the 3-year period of time. Okay, one of the things, and we're talking about when you do the whole entire TCO study that we're talking about, you have to take into consideration software licensing, you have to take into consideration raised floor space, the energy that's being used, and also the people and the personnel needed to be able to go off and manage that environment. Taking all those things into consideration, you'll see those reductions that I just talked about.
One of the biggest things we left out there was downtime.
Oh, yeah. So I haven't, downtime is very difficult to calculate over here. But one of the things that our mainframe is known for is 100% redundancy. When you go downstairs to see the rack itself, you'll see that everything is redundant. Not only from a processor core standpoint, from a power supply standpoint, from the top of the rack switch that we have in there, everything is redundant from that standpoint. When we ship out a mainframe to you, you might have only paid for example, 2 cores or 2 IFLs. We still ship the fully populated box out to you. And the reason why we do that is because if one of those cores go down for some reason, we'll make active one of the other cores that's already inside there. So the reliability that comes with the mainframe over here, though it's very difficult to calculate, is something that people rely on when we talk about Linux without risk. Thank you.
Do you have any predictive failure that you could switch over before the core goes down? Or do you wait till it goes down before you switch?
Well, we can detect when things are going to be happening, and then we switch over. We detect that. Oh yeah, it's non-disruptive. It's non-disruptive. Okay, right here, LinuxONE is designed for minimal downtime over here. Whether you were talking about unplanned downtime of less than 4 hours for each server and the hardware platform over here, if you look at the various different things, LinuxONE's down here all the way down to 0% compared to, for example, Oracle running on x86 where you have 10% over here. So unplanned downtime instances per year, 89%, lower. Time to resolve unplanned downtime, 45% lower. Productivity hours lost per year, per user, down by 94%. Again, because we have been in this business for quite so long, we have not only hardware redundancy that we have inside the box, but we have things that we do within the virtualization space over here to be able to help with that. Okay, so on our platform over here, we have a hypervisor that's been around for well over 40 years. It's called ZVM. And this proprietary hypervisor that we've had has, over the course of the years, has allowed us to be able to do techniques such as memory overcommits, running the server at nearly 100% activity rate over here, this hypervisor that we have over here allows you to be able to go off and do that consolidation that I was describing earlier. You can get more applications consolidated into a ZVM LPAR or partition than you can on any other platform. So there's the density factor over here that's available to you that's you can't get on any other platform. In fact, when VMware started coming into the virtualization business a few years ago, I remember the head of VMware saying that when we grow up, we want to become like a ZVM. So that's what they're striving towards from a virtualization standpoint. And this is something that we have been building and continue to improve. And in fact, we're going to talk about, as part of this presentation, the improvements that we've been making from an OpenStack standpoint to be able to allow you to be able to have ZVM running in the OpenStack arena. We also have another choice over here called KVM over here. I'm going to skip over this in the interest of time. So not only do we have ZVM, but we also have a KVM hypervisor that's out there. And that also provides OpenStack support. I'm going to focus mostly on ZVM over here because the SUSE OpenStack Cloud product that we're going to talk about and demo has support for ZVM. Okay. So from an OpenStack standpoint, with respect to our ZVM drivers that are out there, our Nova support and our Neutron support over here, they're part of the OpenStack GitHub. They're not part of the OpenStack distribution yet. Our plan is to be able to go off and make that available as part of the OpenStack distribution that comes out in the spring of next year, the Okata release. But it's out there available for anybody to go off and pick up and use, and that's in fact exactly what SUSE has done with their SUSE OpenStack Cloud product. They've taken the open source drivers that we have out there in GitHub, included it as part of the SUSE OpenStack Cloud product over here to be able to allow you to be able to go off and manage or put ZVM also in the cloud environment. Okay, why don't I turn it over back to Pete over here to go through some OpenStack Cloud issues, not issues, but the OpenStack Cloud product, and talk about OpenStack itself also.
Thanks, Kershaw.
Sure, please.
I'm not as, sorry.
No, please, go
I'm
ahead.
as familiar with ZVM.
Yep.
So from an OpenStack unit operator's perspective, administrator perspective, if they hit the CLI, what differences are they going to see if they're running on ZVM versus KVM?
So the question, I just have to repeat the question for the recording, is what differences do you see between ZVM and running on x86 KVM?
No, on
the mainframe.
From a CLI standpoint, OpenStack CLI standpoint and OpenStack UI standpoint, you're not going to see any difference. It's the OpenStack Horizon UI and the same CLI that's going to be used for both those environments.
Jump down into the CLI, I'm wondering,
Each one of the individual hypervisors have their own CLI, and they have their own instructions, et cetera, that are there. You need to have familiarity with ZVM that doesn't exist from a KVM standpoint. So there is some education that needs to get done there. You're not going to use your KVM.
hugely different.
Yes. Yes.
So basically, from a command line perspective at the CLI for the OpenStack administrator, you'll use the same Nova and Neutron commands that you would normally do, and there is some translation that is happening between the OpenStack APIs and what's actually and translation to what needs to happen in the ZVM world, but that's all abstracted from the OpenStack administrator.
So first of all, we'll talk real quickly about, for those of you not familiar with OpenStack, what we're focusing on for, if you look at a virtualized environment or a cloud environment, you have end users, you have people that run the cloud, you also have people that manage the physical resources and manage the hypervisor. OpenStack is really targeted towards the end user that wants to consume cloud resources and the administrator that's managing the overall cloud. There are other tools which SUSE OpenStack Cloud does include to address managing the platform and managing the hypervisor itself, but OpenStack specifically is focused on the workload layer, if you will. So what is it? It's open source software. It's a platform to enable customers, to enable enterprises, to enable service providers to stand up infrastructures to service clouds, and that can manage compute, storage, and networking. I also like to think of it as the next version of APIs. I mean, historically, the operating system, like SUSE Linux Enterprise Server, really delivers a set of APIs that abstract away the physical infrastructure that underlies the data center. OpenStack provides a set of APIs that abstract the software-defined infrastructure. So software-defined compute or hypervisor, software-defined storage, which is Open vSwitch, or the various software-defined networking solutions from Nuage or Cisco, people like that, and then software-defined storage, whether it be SUSE Enterprise Storage or pretty much anybody else that's in the storage business today. So the whole idea is it's an API that enables you to manage this set of highly virtualized resources. When you start looking at that, when you start looking at how do I take advantage of OpenStack, you have to ask yourself, what am I going to use it for? Am I going to manage compute? Am I going to manage object storage? Do I want to do both of those things? And then there's a whole bunch of core services you add on top of that in terms of object management, object storage management, the user dashboard, compute, networking, block storage, glance. I've got another slide later on that talks about the proliferation of services that you can deploy as part of an OpenStack environment. You see the additional ones kind of come in here. In terms of where we are with OpenStack, we're on a 6-month release cycle. The upstream, SUSE OpenStack Cloud only releases once a year, so we skip a release. Right now we've been skipping the spring release. So you see April, September. So we've been productizing based upon the October releases for the last 3 product releases, and you can see that there are you've got a current stable release. You have 2 releases that are security supported, and then pretty rapidly upstream goes end of life. Which means that if you're running, and there are still people who are running Icehouse and Juno in production, which is a little bit risky, which is why that you ultimately want to have an OpenStack distribution, because you get the additional support from either a vendor like SUSE who delivers on-premise support, or there are companies that will do managed private hosted clouds or managed on-prem clouds, so that you can decide what level of management you really want. There are people that are running from upstream OpenStack. That's a pretty expensive process. Yes?
As much as you can you explain it as though you were explaining it to a dummy?
Explain which? OpenStack?
Yeah, but as much as you can without taking too long. Pretend I'm a dummy.
I'm trying to think if I've got some pictures that would, well, okay, so let me try it, and hopefully we have pictures. What OpenStack really gives you is a set of tools that talk to the underlying hypervisor. So if you look at historically, OpenStack really was all about compute and how do I deliver minimal storage capabilities to virtual machines. And the OpenStack API was really intended to provide a self-service interface. So instead of having to go, if you were a developer, instead of having to call up your systems administrator and say, I need 5 VMs to deploy this workload, how fast can you do that? Well, give me a trouble ticket and I'll get it to you in 2 weeks. You actually just have a dashboard, just like an Amazon or Google Compute Engine or Microsoft Azure, where you can say, I would like to have a virtual machine that has the following characteristics. I need 1 virtual CPU, I need 4 gigabytes of RAM, and I need 10 gigabytes of hard disk. And then I want to have 5 of those. And you Mike will do the demo. You just type that in, and typically within 5–10 minutes, you've got your virtual machines. And you have complete control over those virtual machines so that you can download an operating system on that and start running it and do whatever you want. So the whole idea behind OpenStack is really minimizing the interaction between the person that's consuming the resources and systems administrators. So the idea is make it as easy as possible for you as the end user to get access to the resources you need without having to call somebody. And so so it started off with pretty simple. It was compute resources and object storage. So if you're familiar with Amazon Web Services, think of it as EC2 and S3. And then over time, there's been more and more enhancement to the process so that you now have the ability to have persistent storage, which is like Amazon Elastic Block Store, if you're familiar with that. And you can now define networks. So I can say, not only do I want to have a set of VMs, but here's how I want those VMs to be connected with each other. And it's all very, very dynamic. On top of that, now you can layer a set of services for orchestrating those virtual machines. Pretty much as possible, have complete control over your infrastructure without having to pull a systems administrator in.
And the whole intention behind OpenStack with this, user interface that Pete was talking about over here is you as an end user will not know whether or not the workload is running, for example, on x86 or, for example, on LinuxONE mainframe. The UI is the same. The OpenStack APIs are the same. So it abstracts that hypervisor layer, that virtualization layer, to the end user. They don't really notice the difference.
Right. So again, just to, there are a couple different ways to get OpenStack distribution, which SUSE Linux Enterprise or SUSE OpenStack Cloud is a distribution. You can have a hosted private cloud. We have service providers that are running OpenStack that will host it for customers, and you can there are customers that are running essentially Amazon EC2 competition on OpenStack. And as the end user, you don't even necessarily know that. IBM also has an appliance that's specifically designed to run on ZVM. And so we'll talk a little quickly about that. The way this whole thing works, and there's two things you can look at. One is what's called managed from and managed to. So if you're running the control plane on something outside of the ZVM environment, that's called managed to. If you're actually running the control plane within the ZVM environment, that's managed from. So you get the horizon, which is the OpenStack dashboard. You get the user interface. It talks to the control plane, and then you have compute nodes, which is kind of what OpenStack does. It talks to compute nodes and storage nodes and sets up the resources. And then there's a plugin that talks between something called XCAT running on either x86 or ZVM, running on Linux in either case, talks to an XCAT instance that's in ZVM, and it uses standard tools within the mainframe environment to talk to the underlying ZVM. So the idea is you say, give me a virtual machine, you go through this proxy, and then ultimately the commands get translated. So Alan, to your point, there is no difference to the end user from an OpenStack perspective because it's all still going through Horizon. It gets translated through XCAT.
Yeah, I know it's not anything for the end user.
Right.
I was thinking more of the COA.
Yeah, you're going to want somebody who understands ZVM.
Sorry, just a question. So if you have it on this, can you then use the same OpenStack to do the provisioning on other platforms as well?
Yes, and in fact, that's what we're going to demo when Mike gets in at the end.
Thank you.
So a couple different ways of looking at the. And I'm going to go over this pretty quickly because we really want to talk about SUSE OpenStack Cloud and how that works. But you can have the controllers or the computes on ZVM or keep them separated. Just skip over this. This is just the list of features that are supported from Nova, which is the actual scheduler within OpenStack. So it's the piece that spins up the virtual machines and attaches the various solutions to that. And the same thing with networking and block storage. So this is CMA's based upon Liberty. So again, the various releases, Liberty, Mitaka, Newton. So Liberty was the last year's spring release, or actually last year's fall release. And then since 2016, there's the ability to run CMA in a so the next release of CMA will work with ZVM 6.4. It will be based, again, on Liberty. There's some enhancements on how that actually works. And then beyond that is the support for OpenStack Newton. Now, OpenStack Newton is the most current production version of OpenStack. And that is what we have just based SUSE OpenStack Cloud 7 on. If you want more details on SUSE OpenStack Cloud 7, I've got a roadmap session, I think at 4 o'clock today. So I'm not going to go into a whole lot of details about that. Now, let me talk about ZVM and SUSE OpenStack Cloud. Just a background, SUSE actually joined the OpenStack community in 2011. Before there was an OpenStack Foundation. We started participating and helped define how the foundation works. Alan Clark has been the board chairman of the SUSE of the OpenStack Foundation since 2012. We had our first release based upon OpenStack Essex in 2012, and you can see we've been releasing pretty consistently since then. Our SUSE OpenStack Cloud 6 came out in spring of 2016. We will release, I should have updated this, our Newton-based release, which is SUSE OpenStack Cloud 7, will come out in mid-January. Now, one of the key advantages that we have in SUSE OpenStack Cloud is that we support what we call mixed hypervisors. So within a single cloud environment, you can have almost any hypervisor you want. We don't do power yet. And the structure of SUSE OpenStack Cloud is you have something called an admin server, which, if you remember the first slide that talked about managing the infrastructure, we said OpenStack doesn't address that. Our admin server is focused on how do I deploy the physical infrastructure and configure that to work with OpenStack. And then we have the control node. And again, one of the unique things that we've done is we've automated the setting up of the control node in a highly available manner. We don't talk about how many nines this can support, but the idea is that I can have outages in my control plane, I can lose a server, but the actual control plane stays up and running. And then you can use SUSE Linux Enterprise Server as the hypervisor host running KVM or Xen or Docker. We support Microsoft Hyper-V. We support VMware, and then with SUSE OpenStack Cloud 6, we started supporting ZVM. And this is, again, just to kind of highlight how OpenStack has evolved. Back when OpenStack first came out, you had compute, which was the compute scheduler, which is Nova, and both block storage and network storage were built into that. And you could run any hypervisor you wanted, really, as long as it was KVM. We did some things to make Xen work in that environment. Now you can provide this wide range of hypervisors. You have a lot of different ways of getting access to both networking and storage. So for example, you can have block devices, persistent block storage. You can set up shared file system. So think of this as a NetApp without having to talk to a storage administrator. So you can say, I want to set up a file share and attach it to the following 5 VMs. Then you have a lot of different services on top of that make it easier for you to control your environment. For example, there's a tool called Heat, which provides orchestration across VMs. So you can say, I want to set up a WordPress application, a WordPress workload. You can define a Heat template that just says, deploy WordPress, and it'll automatically set up your database, it'll automatically set up your Apache server, and if needed, a load balancer on the front end of that. We support a wide range of physical infrastructure, so not only x86, but I got to change this to Z Systems since you guys changed the name. And then the real advantage of a distribution is that we package all this to work together, so that when you go and do the deployment, it's all configured and managed. And we had somebody, I forget what the current number is, it's something like 14,000 parameters that you have to specify when you install OpenStack. So as you can imagine, that's somewhat complex. We automate that so that you go through a simple, almost like a wizard-like process to do the installation, and it takes care of all those.
I think it's about 1,400, not 14,000.
Well.
So, but there's still a lot of parameters.
So SUSE OpenStack Cloud 7, as I said, I've got a session later today that goes into some more detail. It's based upon OpenStack Newton, which is the most current release. It's also based upon SUSE Linux Enterprise Server 12 SP2, the most recent version of SUSE Linux Enterprise. As I mentioned before, we release on a 12-month cycle. Most customers told us there was no way they were going to upgrade on a 6-month cycle. It was just too painful. With the introduction of SUSE OpenStack Cloud 7, you'll now be able to upgrade from 6 to 7 non-disruptively, which means if you have workloads running on x86 or ZVM, if you do the upgrade, there will be you don't have to shut down any of your virtual machines. There'll still be some outage on the control plane or the API layer, but that should be fairly minimal. We'll now support Docker and Kubernetes, so we're starting to embrace containerized workloads more directly. And again, this is a very self-service, so you can, as an end user, you can say, oh, I want to start using Kubernetes and Docker. I spin up the virtual infrastructure to support Kubernetes, and then I start deploying my Dockerized containers, or my containerized applications on top of that. Let's see. One of the key differences from a ZVM perspective is that we will now support both managed from and managed to in Cloud 6, which is what Mike is going to demo. We only do managed to, which means the control plane has to run on x86. So here's the high level. So Alan, to your question, first bullet. If you don't know mainframes, you don't want to go down this path. And we run in managed mode, we run in managed to mode. We support a number of different network configurations. With Cloud 7, you can run the compute node with a ZVM driver on x86 or on System 390X, so on the Linux environment within the mainframe. And here's more documentation on how do you get everything set up on the IBM side, although we have included a lot of that into our more current documentation.
Sorry, just a clarification. So, are you saying this does not work on the ZKVM?
We do not support ZKVM currently.
You do not support it, or does not work?
They have not put any code inside of SUSE OpenStack Cloud.
Right.
And are you going to?
We are looking at it. Just to be clear, currently our existing set of Linux on mainframe customers are primarily ZKVM, or ZVM. Sorry. So we had so we had specific requests from customers with ZVM to do this, which is why we did it first.
But with something in the LinuxONE box now,
Yes.
KVM is becoming more prevalent.
Yes, we understand that. So with that, I'm going to turn it over to Mike to do a quick demo. I think he's going to have to talk fast.
Yeah. So I basically we don't have a System Z, a Z Systems box here. So I connected to our Z Systems box in Nuremberg, Germany, where we have SUSE OpenStack Cloud 6 running the x86 control plane, talking to the CMA. Hold on before you start that there, Pete. Talking to the CMA, which is a part of what IBM provides that helps in that translation from OpenStack API calls to be able to tell the mainframe and ZVM specifically how to start up Linux virtual guests, Linux virtual machines. So this video that we're going to start up here in just a moment is about 4 minutes. It goes through very quickly, but you're going to get to see all of the things that we've been talking about from an OpenStack end user's perspective, but then we're also going to look at it a little bit from an administrator's perspective on the back end, so that you can see, the administrator can see even more, but they don't have to look at these things. I just wanted to show it so that people could see that it truly is. But we're going to also be able to show off very quickly the ZVM instance, the VM running in ZVM. being able to communicate with an x86 instance that also starts. So they'll be able to ping each other and things like that. If they can ping each other, I decided not to spend the time to log them in, but it'll work. It would have worked. So so I think at this point it's going to be very fast because it's 4 minutes. I would normally like to pause it and everything, but we can't get the pause working for some reason. So I'll run through it, and then if you have any questions with regards to the video, feel free to ask, and I think we can go for it. Okay, so this is the SUSE OpenStack Cloud dashboard. We're going to go over to the bar clamps, go to OpenStack. We are going to the Neutron driver. Remember, Pete said Neutron and Nova. We're going to go to the Neutron driver, which is the networking. We're going to go down to the ZVM configuration section, fill out all of these pieces of information that you get from your Z administrator. You're going to go ahead and deploy that to the control plane, which happens to be the Neutron server and the Neutron networking. I had already done that, so I didn't want to take the time. Now we're going to go to Nova, which is the compute portion. And again, there's going to be a ZVM section in here. So I'm going to scroll down. And again, this a lot of the same information from the previous, but we're also highlighting what type of disks are going to be used. And this is all mainframe terminology. So yes, you're going to need to get some information from your mainframe administrator, systems programmer. And then as you can see, I've got a compute node KVM over here, and I also had a compute node ZVM at the bottom. Now we're actually in the Horizon dashboard. So we've deployed everything. I've got 2 images that I can deploy, one of them being an S390X image. That's the mainframe image. That's going to be deployed on ZVM. I'm going to go ahead and select M1 small for a flavor size. I'm only going to deploy 1 image. I'm going to make sure that I select a key pair and default security group, select the networking, and then click on launch. I'm going to repeat the same process for x86. I think I skipped through that pretty quickly because if you've done anything with OpenStack, you're pretty familiar with that process. But as you can see from a user's perspective, deploying a ZVM guest or an x86 virtual machine is exactly the same thing. I'm going to use our SUSE Linux Enterprise Server Juice image. And I'm just making sure that selecting the proper key pair so I can log into them. I'm going to go ahead and associate a network and click launch. And like Pete said, it can take anywhere from a couple of minutes or 5 minutes. So as you can see, it's spawning both of the virtual machines. But it took about 5 minutes to spawn the ZVM because it's a little bit bigger image. But now I'm actually going to log in. So I'm the user of the VM, and you can see I'm logged into the ZVM instance. I do a uname -a. The architecture over here is S390X. I have an IP address. I'm going to try and ping the IP address of the x86 guest. I can ping it. I'm going to associate a floating IP address to the x86, the juice guest. And now I'm going to go and open up a new tab. I'm going to SSH into that guest. And there's the juice image. That's the x86 image. So I just wanted to show some more information about the ZVM hypervisor. You can see it down here at the bottom of the screen. It says ZVM. There's my instance running. That's the name of the instance within the ZVM world. And the reason why I look at that is because I'm going to go over to the ZVM side of the house, the CMA, and I can actually look. I don't have to type any commands as a mainframe operator. I can actually use this tool to look at a lot of the configuration that was done on the Z side. So the cloud administrator can look at this if they're given access and they can say, hey, yeah, this is actually working properly and everything. And now I'm going to go ahead and terminate the instances just as people would normally do in a cloud-based environment. And in a matter of moments, boop, they're gone. It terminates a lot faster than it starts up. But but that's it. That's the 4 minutes of the video. So hopefully that gave you a little bit of an idea of what this thing looks like from a cloud user's perspective. at the end, a little bit of the cloud administrator's perspective, but absolutely, if you plan to do this in your environment, you want to make sure that you have a ZVM systems programmer. If you have a Z in your shop already, you probably know what who that person is, or you're familiar with that term, but absolutely recommend getting somebody who understands the architectural pieces of Z, because there are some things that you want to make sure that are properly set up on that side. So with that, any questions? Yes?
What sort of security is there around terminating that instance? Can you set it up that you have 2 levels, or that nobody can do it? Or?
So the question is what levels of security are there for terminating instances? So that's actually, you have to go back to the origin of OpenStack and why OpenStack was created, to allow people to easily request instances and virtual machines, use them for the purpose that they need them for, and then destroy them when they're done. So from a security perspective, well, first of all, so basically that means that there is no real level of security. If somebody is assigned to that particular tenant, that particular business unit, that particular group that has been given access to create virtual machines, if that person wants to destroy that virtual machine and terminate it, they can do that. Now, there is the concept of tenants within OpenStack. So you and I may be part of the same business organization, but you're part of Project A and I'm part of Project B. I've been given access to Project B resources in OpenStack. You've been given access to Project A resources in OpenStack. I won't be able to log in unless I'm authorized to get to Project A. And then at that point, usually you have one person that is within that project that's going to be responsible for setting up these virtual machines. It's going to be an analyst, or it's going to be some kind of architect that's going to be working with the developers, talking to the business folks to understand what they need. And so you can limit by just the roles within the project on who would have access and things like that. If you want to just give developers access to spin something up and tear it down, I wouldn't assign a developer to a particular project. I give them their own tenant that's a development tenant. They can go ahead and do their their development work, push it up to GitHub or whatever source code control system they have, and then you as the project lead for that project can then suck that in and incorporate it into your longer running instances. Does that make sense?
I understand what you're saying. I'm not sure
well, I mean,
companies would want, but especially on the mainframe.
Yeah.
Well, it's true. It's true on x86 as well. I mean, effectively, what you're doing is you're giving the person who starts a virtual machine, they are the systems administrator of that virtual machine. So they have complete control over whether it starts or stops. If it's an end user, so once you've started the virtual machine, if somebody's logging in and using the virtual machine, you can treat them as a user. And so they don't have any systems abilities whatsoever.
But more like on the development side, so I'm busy developing something, it's 18 months old, I'm a disgruntled employee, I leave it that point, I delete it, and it's gone.
Yep.
Hopefully there's other controls within your organization around source code control, checking in of the source code and things like that. And remember, there's also, OpenStack is very much involved in the DevOps type of story, and it fits that story extremely well. But using OpenStack may not be the right tool for the job in all cases. So if you know you're going to have a long-running virtual instance, you could actually spin up that virtual machine outside of the OpenStack environment, not have it managed by OpenStack, and that way there's more controls within your organization over that, the traditional way of managing virtual instances within ZVM or any other hypervisor. So I think it's just it's a different mentality. When OpenStack was first created, the the project was created, the mentality was give people access to resources. Let them start them, stop them whenever they need them. That's the flexibility that OpenStack provides. It may not always be the right tool for the type of project or job you're trying to accomplish. So you got to make sure you understand that as you're working and architecting how OpenStack fits into your organization.
I think with all technology, as it becomes more mature, as it becomes more business critical, the security features of it also need to grow with it.
So that's a very valid statement, and the OpenStack security model has evolved significantly. You know, Mike was talking about you can have, I mean, in the first releases, you had somebody who had control over all of the cloud, and then you could assign a project, and then the project was almost, you know, everybody had access in the project. You now at least have two layers where there's a project administrator that can manage the user IDs underneath of them. There's also a lot of work going on in integrating with external security databases like LDAP or something like that, where you can start to do more role-based security. So I don't know if every command is going to be controlled or not, but certainly, I mean, I guess it's possible that you could do role-based security. So you can create a virtual machine, but you can't delete a virtual machine.
And from an OpenStack standpoint, you know, OpenStack isn't in the business of doing something specific for one platform versus another, right? They want to make sure that whatever function they provide works on, you know, all platforms. So while it might be alien to, you know, the mainframe environment to be able to allow an end user to destroy a virtual machine, in the x86 world, it's a common thing. And you know, to be a little blunt over here, OpenStack right now is very, you know, x86 focused, and so they're not going to go off and do something specific for one platform and not for the others.
I think the question is, can administrator control the destroy virtual machine applications? So answer is it's no.
Right. The same user who created it.
You can create, destroy whatever you want. If you want protective, then use your independent VM separately somewhere else, not in OpenStack.
Or remove his rights.
I'm sorry?
Or remove his rights.
Yeah.
Right. Great questions. Any other questions?
So, I'm more from the cloud side of things, so I don't know a lot about the mainframe, but this sounds more like a Linux to Linux migration. And I'm wondering more from like a Unix to Linux migration going into the
Yeah, I mean, the workloads that you saw over here, for example, that we have running, you know, those workloads could be running inside the virtual guest that you provision using the OpenStack technologies. So if you have, for example, workloads that are running in a Unix environment, and you want to, you know, allow it to run in a Linux environment, that migration effort of Unix to Linux should, you know, be pretty much seamless from that standpoint. But you know, the ability to be able to now introduce cloud into the picture over here, to be able to say, I'm going to use OpenStack to be able to go off and provision those environments and then have those applications run in that Linux virtual guest that just got created, should be very possible.
And ZOS to SUSE, and then looking at moving that into the cloud.
Well, ZOS, I mean, I know ZOS has Unix system services, and from that standpoint over here, if you have applications that are running today in ZOS Unix system services, that application that you have there is going to have to get recompiled to run in a Linux environment. Now, whether or not you're going to be able to go off and do that or not is a different story over here, because, for example, that Unix system services application may very well be using ZOS-specific data, you know, data that resides in data sets or in vSAM data sets, et cetera, that are not available to you on the Linux side over here. So moving over a ZOS application to a Linux application, to a Linux environment, is going to be a lot more difficult than taking, for example, a Unix app, say, for example, HPUX application running on HPUX to a Linux environment.
So the way I think of it is you've built up your infrastructure. Customers have built up their infrastructure, and they have their list of applications that they run. And some of the applications are going to be running on Windows. Some of them are going to be running on Unix. Some might be running on Linux. What OpenStack really does very nicely is removes you as the end user. You no longer have to go to IT when you want to start up a resource for a particular project. IT has done all of the work to create the images, to make sure that it has the appropriate applications in it. And then OpenStack is smart enough to say, this image is supposed to go on x86 and run on Windows, because it is the most cost-effective place within the most cost-effective option within our organization. But there are, like the Oracle conversation that Kershaw was talking about, where that is extremely cost-effective on Z. When a customer says, I want Oracle, and I want an Oracle database server running on Linux for my particular project, you as the end user say, I want that Oracle database, and I need this particular size of system. And behind the scenes, OpenStack is saying, okay, I'm smart enough to know that Oracle database is going to be running on Linux on Z. And from an Oracle perspective, your Oracle administrators are going to log in and they're going to say, oh, okay, this is Linux. I'm running Oracle. I'm good. But IT is still controlling the best place to place the virtual machine for the application that's running on that virtual machine, so that your organization is saving money. So it's literally like cloud, but it's actually even, I think, even better because of the multi-hypervisor support. It gives you the flexibility to say, based on my application, I know that this is going to be placed on the most appropriate hypervisor of choice for the application that I'm running.
Okay, I think we're at the end of the session. So thank you for attending, and obviously we can come down to the technology showcase. People can talk about cloud, can talk about LinuxONE. So if there are any follow-up questions, we can see you down on the floor. Thank you.
We'll just stick around for questions that you have here.
Yep.
Thank you.